No clickers. Okay. Good afternoon, everybody. I'm Bob Pianta. Welcome to the session, Designing Teacher Evaluation and Support Systems, New Guidance for Educators and Policymakers Emerging from the Measures of Effective Teaching Study. We have a full lineup of talks this afternoon derived from the MET study and the use of its data set to illustrate application of those data for problems of real applied interest. I think you'll find each of these papers both very unique in the way that they've intersected the MET study with problems that the field faces and an illustration of the kind of work that can be done empirically in the science of teacher effectiveness. The lineup we have of speakers today will be in the order as follows. Steve Cantrell from the Bill and Melinda Gates Foundation will be speaking to us. Eric Ruzick, Ron Ferguson, Tom Kane, and Dan McCaffrey, we hope will join us right at the end. He's coming from somewhere else. Right, Carrie? Is that crew? Okay. The ground rules are that we're going to move through these talks actually fairly quickly. Each presenter will present their paper, but then we'll have time after each talk for a short period of time after each talk for questions relevant to that talk rather than save everything at the end. So we'll save about 5 minutes before moving to the next speaker for each talk. So with that in mind, I'm going to turn it over to Steve.
Spacebar works. Welcome, everybody. I'm thrilled to be here. My main task right now is to answer the question, what is MET? And what I want to share with you, because most of you have heard about the project and many have ideas about what it is, but I want to let you inside for a moment to understand how MET is first and foremost a partnership. Second, it's a proof point. And third, it is a perspective. So let me direct you to our website if you haven't been there, metproject.org, which has all the publications, all the research briefs that you would ever want to read from the project. So it is the main repository. Let me talk about the partnership, because the partnership is the most important part of MET. These are many organizations. I see many of you in the room today from those organizations. We would not be here in front of you if we did not have people from these fine organizations behind us. Absolutely critical. The number of people working on MET at its height, not including our raters, was over 200. So it was a tremendous collective effort. Perhaps most important, though, are these 7 school districts and the 3,000 teachers who volunteered to let cameras into their classroom to give extra assessments to their students, to ask their kids to assess the quality of their instructional environment. Incredibly brave work. And I think they will have proven to have significantly advanced our understanding of what constitutes effective teaching. So MET was a proof point, and this is the money slide from MET. What MET proved is that it is possible to measure effective teaching. I won't go into the details of this. I'll direct you to the report. But that is the question MET sought to answer. And it established, just for your information, that is not the line of best fit, but that is actually the line of perfect prediction. Moving on, MET is also a perspective. And the perspective emerged from both the partnership and the problems of practice that our partners wanted researchers to take a look at. And the proof point. Many ways, the data shaped the questions that our partners were asking. One of these perspectives is, how is it, and problems of practice that many districts are dealing with right now, is how is it that we build an evaluation system that is going to contribute to the improvement of learning for our kids? And that answer is not obvious. And as we've dug in, we realized it's got to be more than teacher accountability, that this really needs to be informing the system at all levels. And we suggest there's 3 things that districts ought to be thinking hard about. 1 is measuring with multiple measures. 2 is paying a lot of attention to the quality of data. There's no reason why researchers need to have a monopoly on high quality data. School systems can produce it as well. And then 3rd, that this is an investment in improvement. So one of the perspectives on MET was that MET is feedback and evaluation using multiple measures that teachers can trust. That was our tagline that evolved. One of the ways that you get to trust is through transparency. And we suggested to our partners, and many have adopted, transparent displays that can help teachers and schools and the whole school system understand the shape of the performance distribution in ways that nobody had insight to before. This is an example of that, suggesting that a rank is not going to be sufficient, a number is not going to be sufficient, that most teachers are average but for different reasons, and understanding those reasons is important if we want the system to improve. And then finally, transparency is important to our research colleagues as well. And to that end, we've actually established the entire MET database at ICPSR for research use. So if you are research qualified, and most of you in this room are, literally have access to the entire corpus of the MET data. And we'd encourage you, should you be interested or your doctoral students be interested, follow that link. And it is perhaps one of our lasting gifts to the field. And finally, the first product of that exploration was actually the people who contributed to the MET project, but weren't necessarily the writers of the reports, contributed an edited volume that Josie Bass will be publishing very shortly. I get to hold a copy in my hand, which is great, because if anybody's written a book, you know this is harder to deliver than a baby. Anyway, we're thrilled. I'm going to pass it. I cannot say that. I cannot. Thank God I'm adopted. Eric, it's yours.
Okay, if we only make one of those, mistakes in every presentation, we'll be all right. Can't promise I won't make more than one. Okay. All right. Sorry. Okay, so the chapter that we wrote, my colleagues at the University of Virginia, including Chris Hafen, Bridget Hamry, and Bob Pianta, we really wanted to try to puzzle through how a district might use some of the multiple measures that are contained within MET to create both an evaluation system and a system for assigning professional development and training to their teachers. And as we took on this task, we had the belief that beyond improving student achievement, which is the ultimate goal, for teachers the ultimate goal is really how do we improve the quality of their instruction if it needs improvement. And we think of the 2 big pieces, observations and value added. We think observations provide the more actionable information as you think about what is it if you could diagnose what a potential area for improvement is, the observation is going to provide that diagnosis. And this has implications for training and professional development. There are very critical questions like, do we continue on the path of providing the same professional development for all teachers, the sort of seminar-style one-and-done approach, or do we more strategically target teachers below certain threshold points where we know that if we move them beyond that point, we'll see real gains in student achievement. And, relatedly, do we apply less or more intensive approaches to professional development? And we do think that a good accountability system can aid in this process. But the key is to find the meaningful chunks of or groupings of teachers, the threshold points that can trigger action around professional development. So the MET data really served as our little playground to do this, and it's not a little playground by any stretch of the imagination, and gave us the opportunity to work with a large set of data on a diverse group of teachers from all over the country, teaching at multiple grade levels. The question we challenged ourselves with is, what are the different ways we could build a teacher effectiveness system that will inform not only student improvement and performance, but also improving performance. There were many awesome measures in the MET that we could have used in our analysis. We used the classroom assessment scoring system because we're intimately familiar with that at UVA. But the analyses I'll show could equally have been applied to Framework, MQT, or Plato. So here are the three classification schemes very, very quickly. One is to use sort of an external metric for creating groups of teachers. And in the class manual and documentation, it's actually identified what we think of theoretically as low, medium, and higher quality interactions that teachers have with students. Another way is to simply use the distribution of scores in the MET sample or in a district and chunk the data based on the distribution at different percentiles. And then a third approach is more iterative, more data-driven, but it's really to identify points along the class score distribution at which the association with student learning or value added grows appreciably. So let's start with the distribution of class scores. This is year one MET data, teachers in grades 4 through 9. You can see classes on a 7-point metric. Most of the points of data are chunked in the 3 to 5 range. So if we use the class manual to sort of as an external check on what might a categorization scheme be, what we see is that as we think of the quality of teacher-student interactions, only about 1.2% of the MET sample actually fall into that lower quality. Pretty much 99% of MET teachers were in this middle group. And in order for any sort of categorization scheme to work, you have to have teachers in the bottom and teachers in the middle and at the top. We don't have that here. So an alternative approach is to use the distribution of scores in the district and think about ways that you could chunk those. So we do a lot of different ways in the chapter. To save time, I'm only going to present one of them. And this one would be to find the bottom 10th percentile and make that your sort of lowest category. Have the next 40% and 40% after that be the middle categories, and then the bottom 10% or the top 10% be your highest or most effective category. And when you do this, it's meaningful to look at the graph and to see where those data points fall. But sort of the bottom dollar question is, how do those relate to value-added scores? So here we have a graph that shows you the mean standardized value-added score for teachers in each of the categories, and we've labeled them in effectiveness terms just to make it more easily accessible. But essentially what you see is that in each of these different groups, as you go from left to right, you see kind of a nice stair-step pattern in the value-added scores that they're increasing. In the chapter, we look at different ways to cut this distribution. You could do equally 25, 25, 25. You could have a larger percentage of teachers in the tails. But this one seemed to be a nice way to illustrate this approach. So in terms of the information that that kind of analysis provides, it it tells districts, you know, if you cut up the data in a certain way, what does that look like in terms of where the value added scores? But districts are really interested to know how can they use this kind of multiple measure information to gain the most purchase on their professional development dollars. And the two approaches that that I showed previously don't really tell you that information. And so the alternative way that we looked at this was we used a technique called spline regression, where we essentially looked across different points of the class score distribution to find class score ranges where the association between class and value added was greatest. So back to the distribution, we actually found 2 points in the first. This is all first year MET data. In the first year of MET, and there was an upper and lower point. And as you can see, they chunk the data differently than the categorization does. And so, to give you a better sense of you know what it actually looks like, this graph does a nice job. So what we did was we at these two different ranges, the lower range is at 2.91. When you look at the association between class and value added below the 2.9 threshold, you see that it's a nice, that's a standardized coefficient of 0.25. That's a decent effect. But in the middle, you have there's almost no change associated with value added as you go up in class scores until you get to the 4.5, at which the association again takes off. And as you can see, we have a very small percentage of teachers in that the bottom category in MET, and a much larger percent at the top category. Where do these 2 points sit in the class? You can see that they are right in the middle, and all this suggests is that there's a lot of room for improvement if in the class metric in terms of what we can do with teachers. So we think there are a number of implications for professional development, and some of the options that are available are highly dependent on resources. So the money that school districts have available, the level of intensity and time that they want to devote to professional development, and the number of teachers that they want to target their efforts at. And we think, you know, as using data to make these decisions about how to allocate resources is the only way to go. Now, in terms of types of PD, you know, this is a question that school district leaders and state officials always want to know. Well, what can I do to make changes, to make improvements? And there's varying levels of intensity and effort that can be put in. At the very lowest level, you know, having a database of high quality instructional exemplars that all teachers can access and reflect on and think about how what they see in these videos could relate to their own practice and how they might alter their practice based on what they see as the exemplar. That's a possibility. At maybe the highest cost or highest intensity would be instructional coaching, which a lot of work in PD in education has started to think about coaching as an effective way. And with coaching, because it's higher cost, higher intensity, you might only deliver it to a selected group of teachers. Bob and others at UVA have done work on a coaching program called My Teaching Partner that's been used in pre-K through secondary schooling. And it was built around the class. It was framed in terms of class language, but in subsequent projects we've been able to mesh it with school districts' own frameworks that they use when they talk about instruction. And what's really exciting about My Teaching Partner is that it has demonstrated effectiveness in random assignment studies. So what we've seen is that when teachers are assigned to the My Teaching Partner coaching in secondary schools, they show a 0.20 increase in their class score. Well, you might say, well, that doesn't sound like very much. Well, in the MET data, the first year of MET data, that was approximately 35 to 45% of the standard deviation of class scores, depending on what grouping of grade levels you looked at. The policy implications, I mean, the one I think that's really important is that we want districts to use their own data. I mean, what we've done here was more illustrative. We wouldn't want a district to go out and take you know, the thresholds in the MET or the categories that we came up with, and make decisions around those, we would really want them to look at their data and go through these sorts of careful analyses that we've sort of laid out in the chapter. And we think that's, you know, it might be difficult on the one hand, but it's also very exciting and liberating when when a district can make the decisions about, you know, and they can do it in collaboration with their teachers around what is going to work in our context. And we just think that's fantastic. We do it all the time, but we want to encourage more people to do it. So thank you very much. I appreciate your time.
We got a couple minutes of questions. If anybody has any questions for Eric's followed up on his talk. Yes.
I'm curious how robust this is or consistent it is from year to year. You look at it from year to year. In order to determine to what degree essentially the teacher effect or reverse that the students make the teachers.
Yeah. So you know, one of the things, a couple things. We only looked at this in year one. We didn't do it for year two. And the other thing is we didn't use the year two data, so we can't really make any causal claims. Like, you know, there were no teachers weren't assigned any sort of professional development around their class scores. This is simply, you know, it's an observational analysis. I mean, those are important questions, though.
Other questions for Eric? Yes.
I wasn't clear who the target was for the professional development. Was it a group that was
Well, yeah, so the question was, you know, if you, based on the data, where might you target professional development? And I think that's sort of, I think that we could probably have a long discussion about that. Like, if you think about the thresholds, you know, you obviously would want to hit that group at the bottom, because anything you do there is, you know, you're going to see big improvements. But around that top threshold, you know, do you want to focus on teachers whose class scores are above that, or maybe right adjacent to it, and move them into that more active range? I mean, I think that's really sort of the interesting discussion that districts can have around this type of approach.
One more, yes.
What grade levels was that data from?
That was grades 4 through 9.
Just quickly back to this point here, I think part of what we were trying to illustrate is that because there are different points along the distribution where you see relationships with value added, then that allows for engaging in a data-driven conversation about how to deploy resources to move teachers in one place or another, rather than just say, oh, we don't know what to do, or we do the same thing for everybody. I'll turn it over to Ron Ferguson.
Good afternoon. I'm going to be talking about work that Charlotte Danielson and I did for this paper that brings the two frameworks together and asks about the degree to which the student's perspective of life in the classroom matches up with the teacher's perspective on life in the classroom, particularly perspectives about what the teacher is actually doing here. I also want to emphasize at the outset that I've been doing this work for probably about 12 or 13 years. Charlotte, probably more like 15 to 20 years. And for that entire period, our emphasis has been on improvement more than on evaluation. And it's only very recently that people have started trying to use the evidence for evaluation. And there's probably not any better evidence to use for evaluation, but it's the big challenge for us is to keep the focus on improvement. And the evaluation is a secondary use of the data. And I think that's an important precursor here. My work grew out of work in school systems with teachers and administrators who wanted to understand more of what was going on in the classroom so that they could intervene more effectively to support teachers on improving in the classroom. What I'm going to cover today, the alignment of the frameworks, the relations of each to value added, the relations to some other student outcomes, difficulties observing classrooms where control is low. When you've got classrooms that are rated low on classroom management where the kids are out of control, it's really hard for the observation tools to distinguish anything else about the nature of instruction. And I'll address that a little bit. And then quality control by cross-checking the different metrics. There's a probability distribution that the combination of these things should follow. And if you get a case where the student ratings and the teacher ratings are too similar or they're too dissimilar, there's something strange going on, and that gives you some cause to want to look into it a bit more carefully. Background on this, you know there's 6 districts. I used 4th through 8th grade data here from the first year of Med, just like the paper you just heard. English and language arts. Initially, I was trying to do this analysis separate for English and language arts, but there were little differences, but they were not statistically significant differenes. And there's so much else in this paper, I just combined the two. So I'm using both the accountability test scores and the non-accountability test scores all in one z-value, one measure of value added for the classroom. And all the metrics are z standard deviation of 1, the mean of 0, and net of student background effects. So everything here we're using has been net of the background effects we have. I'm only looking at within school effects, so we've got school level fixed effects for everything. Everything is playing off within school variation in what we're looking at here. In Charlotte Danielson's framework, there are 4 domains in the standard framework. You'll see them on the screen here. The MET project used the middle 2 domains, the things that have mainly to do with what you observe when you see that classroom. The classroom environment and instruction being the 2 domains. With regard to alignment of the 2 frameworks, the first column here, you see the domain of classroom environment, creating an environment of respect and rapport, managing classroom procedures, managing student behavior are the components in the domain of classroom environment, whereas in the domain of instruction, you've got the things you see here, questioning and discussion techniques, assessment, using assessment and instruction, engaging students in learning, communicating with students, establishing a culture of learning. On the tripod, we talk about the 7 C's of effective instruction. And you see at the top of the screen here, in the domain of press, we have challenge and control. And within challenge, there are really 2 sub-concepts, which one is rigor, the other is persistence. So we have teachers challenging their students to think rigorously, in other words, try to understand, not just memorize, help explain to me why it is you think what you think, but also press for persistence, which is things like my teacher doesn't let students give up when the work gets hard, or my teacher pushes everybody to do their best work, and those kinds of ideas. And then under control, there's really minimizing misbehavior, the presence of good behavior, and being on task. So our class stays busy and doesn't waste time. So we've got those things all under control. And then support, you see confer, captivate, clarify, consolidate, and care. And they mean pretty much what you think they'd mean. Care, in this particular case, is a teacher who's sensitive and emotionally supportive. Another sense of care picks up challenge. When we ask teenagers, what do you mean when you say a grown-up cares? We get the same answer in lots of even different cities. And the answer is somebody who really cares about you does things for you they don't have to do and they won't let you give up. That's more challenge in our framework than not letting you give up a piece of that. But what we find is that the press domain in tripod is more closely related to the classroom environment domain in the framework for teaching. They both have to do with classroom management, having an orderly on-task classroom. The instruction domain in framework for teaching more aligns with the support domain in tripod. And I'll show you as I go through that the empirical findings also sort of validate this notion that they align in this way. The alignment in here, this is conceptually, if you go through, there's a page in the back of the chapter that'll be out in the book where we have a blurb on each of the C's and on each of the FFT components. And we kind of match them up and have the arrows and what they match to. We then, in the next slide after this, I show we check this empirically. You could take a particular C and see how it's predicted by the FFT components you think should, or you could take the FFT component and see how this is predicted by the C components you think should. There's a table that shows they do predict in the way you'd anticipate after you've broken them up conceptually. But just on the screen here, care aligns with the environment of respect and rapport, confer, culture for learning, questioning, discussion, communicating with students, all those have to do with that eliciting student perspective, respecting what they have to say, asking for feedback, and so on. Captivate, engaging students in learning, the language and engaging. We'll pick up some captivate stuff. Clarify, questioning, discussion, communicating, assessment, consolidate, questioning, assessment, challenge, culture for learning, questioning, engaging students, and control, the top 3, respective environment, managing student behavior, and classroom procedures. Here, the print is small, but this just shows that almost all the relationships that are on that chart right there hold up statistically when you just run, where the predictors are only the ones that you would have predicted to be predictors, and they are significant. All these frameworks, you get high correlation between components. And I should say that. But here we're just using things that were theorized to be predictors to confirm that they really are across frameworks. Now here, on the axis here, you'll see all of the components for both tripod and FFT. And they're rank ordered. Wait a minute, go back a slide. They're rank ordered in their relationship to value added. And let me explain what we did. For each of these components, we broke them into quintiles. So 20%, 20, 20, 20, 20, right? And then within each component, you can ask what's the average value added within each quintile. Okay, so for example, at the bottom of the screen you see control. You break control for the whole sample into quintiles. And then what the graph is showing is how much different the average value is in the second, third, fourth, and fifth quintile compared to the first quintile. So basically it takes value added in each quintile and subtracts off value added in the first quintile, right? And so here you see control. I just keep trying to use the pointer to show you, since I don't have a laser pointer down here. There it is. See, control is the one that has the strongest relationship to value added. Usually when I ask audiences of educators to guess, they guess care. And you see where care is up the top. Has the weakest relationship to value added of any of the metrics from either framework. But the strongest four predictors here in terms of the fifth versus the first quintile are all tripod metrics: control, challenge, clarify, and captivate. And then we get to the control or the classroom management components from the FFT framework. And in each case, what you've got are the two press categories here, challenge and control, from tripod, and then managing student behavior, classroom procedures, environment, respect, and rapport, which are the press categories from FFT, being the most strongly related to value added. The other thing you'll notice is if you look at the students' responses, the step rank order always obtains. Okay, as you go up even through the middle of the distribution, the fourth is higher than the third, is higher than the second. But when you get below the classroom management level for the classroom observations, it almost seldom obtains. It looks like observers observing classrooms can't tell the middle classrooms from each other in the same way that the students can observe middle classrooms, at least with the FFT. That turns out to be the case. Although I'm reminded that flat region in the middle of the chart we also just looked at, right? I should also point out here on these charts here, these are charts that do not include the bottom quintile on control. When you include the bottom quintile on control, and you're looking at the relationship of tripod to FFT, control is always the strongest predictor for every component of the FFT. So how the kids are behaving as the kids report is the strongest predictor of all 8 components of what the observers say. It's only after you take out that bottom 20% of classrooms as the kids rate them on control that the FFT starts to be more variegated in its relationship to the tripod components and so on here. So it's really hard that those you got the point. The other thing I'll point out is when we think about the threshold issue that Eric talked about in his paper, if you compare now with control, the steps are kind of even as you go from the fifth to the fourth to the third and down. But look at challenge. The fifth is twice as high as the fourth. Similar for clarify and captivate. So those top 20% of teachers on challenge, clarify, and captivate are way better than the others on value added. So we get the same kind of discontinuity that they talked about. Now here is, I think, what interests people most about this paper, which is here, if you look, let's say we're predicting value added at the top of the screen. And for here, I've got the classroom environment versus instruction. And we see classroom environment is the tallest on this side, the strongest predictor of value added. And actually, the instruction is only significant at the point not at the 0.1 level, the 90% confidence level. And over here, I've got challenge, control, and then all 5 of the support C's together. And in each case, we've got the press measures are the strongest predictors of value added. Okay. Now, holding constant press, if kids report more support, what might be going on there is that you've got a teacher who is demanding that they really learn it, that they stay on task, and imagine the teacher gets a little bit nicer. Kids take a deep breath, they relax, they're not feeling quite as urgent, and maybe they don't work quite as hard or concentrate quite as much. But Steve Rautenbush and his colleagues have another paper in the same volume that finds the same thing. I mean, he chooses arbitrarily one of the 5 support C's and he uses clarify, but he also finds it comes in negative when you are used in a multivariate way when you're predicting this. We basically find the same thing that Rautenbush finds. And you might be led then to say, well, then we just need to be measuring press if we're interested in accountability. But then you look to see what predicts. Kids say, my teacher in this class inspires me to want to go to college. For 7 C's, it's entirely support. There's a little bit of challenge there, but and even over here, it flips around. That 0.06 with a 0.1 significance level shows up now on class environment instead of instruction, and we get all the bang for our bucks in predicting college inspiration is coming out of instruction. Similarly, happiness in class, more challenge predicts less happiness in class, which is not that surprising. And you see, it's all support and instruction. It's in instruction here. And so predicting effort in class, it's both. It's the student's perception of their own effort. So if we think about how the C's matter, they all matter. But they matter for different things, and they're valid as predictors of different things. And balancing out the emphasis on value added with also an emphasis on longer-term inspiration and happiness in school is an appropriate direction. And it's not that we don't care about value added, but I want my kid to come home from school and say, I had a good day today. I'm happy about that. And also, I think I want to go to college. My teacher inspires me. Okay, it's the support measures that do the latter. Here, this is just showing you some stuff about what happens with control when you keep the bottom part in. We don't have time to look at that in any detail. But here, I'm interested, well, what if support works through, what if the support items get to value added by affecting control and challenge? So here I'm just playing around with it to decide, well, let's look at how the other 5 C's predict control. And you'll see consolidate doesn't predict it, and care actually predicts negatively. So the higher the teacher, more caring the teacher is, the more out of order the kids are, we're finding. But clarify, captivate, and confer are all strong predictors, with clarify the strongest. So the class is most in control when the teacher has the greatest ability to clarify stuff. And on the other side, challenge, you see a very different pattern. There, again, clarify is the strongest, closely followed by consolidate, but then captivate doesn't do anything. So how interesting the kids make it, the teacher makes it, so that it doesn't really give you anything on whether the teacher is being challenging or not. Okay, so this is a chart. The first column is the actual distribution in MET. It shows the percentage of classrooms for which where both variables are above average, and if you come down, it looks at the percentage of classrooms in any particular area under the distribution. And if you go across, you could say, what's the likelihood you get that percentage for 2 pairs in a row? You got a classroom teacher, the kids' ratings, and the observers' ratings, and they have a relationship to one another. What's the likelihood you get the same relationship the next pair class, and the next one, and the next one? And it goes down fast. And so there are patterns that you can pull up in the relationship between the students' responses and the teacher responses that are very unlikely if you're just following the normal rules of probability. And so in the last slide just reviews what I am on, and I think I finished exactly on time, right? All right. Okay.
Thanks, Ron. Hang on one second, Tom. Ron, questions for Ron? Yes, please.
You mentioned at the beginning that your work and Charlotte Danielson's work was mainly to improve teacher effectiveness, not for evaluation. And I'm wondering if you have any sense in which using these tools for evaluation has made them less useful for improving teacher effectiveness?
It has made it more difficult to get around to the conversation about teacher effectiveness, right? I don't think it makes it any less useful, but it's a more difficult political process to get people focused on the use for effectiveness. I mean, I do think we need to have some way to do evaluation. We have to have some way to know what's going on in the classroom. So I don't think it's either or. And I think we have to be grown-ups and get to the point where we can do both without having either use interfere too much with the other.
There's another question way in the back. Yes.
I'm wondering if you used it with special education teachers and how outcomes can compare with general education teachers.
Yeah, we have used it with, I think there's some level of student disability that beyond which you don't want to use it. But with regular special education students, we've used it. You get kind of what you'd expect. They sometimes report a little bit worse. I've only talked about the 7 C's. We got a whole elaborate student engagement piece of it. The relationships of student engagement to SPED versus not SPED are kind of what you'd expect them to be. They self-report slightly worse behavior in class, and so on.
Just a point, I checked with Steve that in the MET data set, there are children identified for special education if they were in the mainstream teacher's classroom. So that's a question that could be addressed in the data set. One more. Yes, please.
Between student characteristics and reports on the 7 C's, there are some. Everything I use is net of the student characteristics. Okay, so the standard things that you have in data sets, we're using what's left over after you take the effect of those out. Okay.
We can probably squeeze in one more if there's one more question. Yes.
I'm wondering about the interaction between the control and the support factors. So I'm wondering if it would be interesting to consider teachers who might be high on both, high on grant.
Yeah. Yeah. No, we have. We've done a lot of things you can imagine we've actually done, and they're very interesting, but we couldn't present it all. Okay, you can take teachers who, I mean, if you chop up the constructs into 3 or 4, you know, like I did here, where you've got control, challenge, and support, and maybe you take each of those and you divide those into thirds, and you have 9 different types of teachers, then you'll see different patterns for each of those types of teachers, particularly with the way their students engage and various other things.
So is it best to be high on both?
Oh, yeah, it's best to be high on both. Yeah. Well, depends on what you're trying to predict.
Right.
Okay? If you're trying to predict happiness, it's best to be high on both. If you're trying to predict value added, and you've got a teacher who's really high on press, then adding support brings the value added down a little bit. If the teacher is low on press, adding support brings value added up. Okay? In the paper, there's a diagram, and it's nonlinear. Okay?
Okay, we're going to.
When the book comes out on
the book
July
will be
8th.
out very soon. Yeah. Okay, going to turn it over to Tom Kane.
So, Steve, if I'd known what it was going to feel like to deliver this project over the last 4 years, I would have asked for an epidural. So, hello, I'm Tom Kane. I'm a professor at the Harvard Ed School. In this work that I'm going to be talking about today is joint with Doug Steger, an economist at Dartmouth College. So first we just wanted to start with a seemingly irreconcilable debate. So first, there was a report came out from Economic Policy Institute a few years ago saying there's broad agreement among statisticians, psychometricians, economists that student test scores are not sufficiently reliable to be used in high-stakes decisions. And on the other side, a paper a few years ago seeming to say just the opposite, that even unreliable performance measures such as value added can identify substantial and lasting differences across teachers. What I'm going to try to do today is reconcile these two different views, because they're not actually disagreeing about the facts. There are 2 points I'm going to try to make. First is that it's the year to career not necessarily the year-to-year correlation that matters for most policy decisions. And the year-to-career is much larger usually than the year-to-year, even though when people talk about it, they almost always cite the year-to-year. Second is that this classical hypothesis testing framework is not really appropriate for tenure decisions. So thinking about constructing a confidence interval with these value-added measures and only being willing to act if the confidence interval doesn't include the mean teacher, I think is just the wrong way to think about it, and we're just misapplying classical hypothesis testing when we do that. So first, just the year-to-year versus year-to-career. So first, the year-to-year correlation, and this is just an identity, just to be able to show how it's related to the year-to-career. The second calculation is what the year-to-career correlation. Now, the numerator is the same, so it's the variance in the underlying signal in terms of teacher effectiveness. It's the denominator below that's different, which includes, as every correlation coefficient does, the standard deviation for the two different variables that you're calculating the correlation for. It's just you have to do a little math to show that when you do that calculation, what you discover is that the year-to-career correlation is just the square root of the year-to-year correlation. Now, for anybody in the audience who's a psychometrician or a statistician, this shouldn't be a surprise at all. That all we're saying here is that the correlation between the measured scaled score and the underlying true score is just the square root of the reliability. Now, in psychometrics and in many applications, that's a hypothetical calculation. However, here in the value-added world, it's this correlation that you want, because typically what a decision maker is doing is they're saying, okay, we've just got this year or two worth of value-added data. I have to make a decision among probationary teachers, and I'm trying to make a decision about whether or not this teacher is going to be having positive or negative effects of students, not next year, but over the rest of their career. So it's actually the year-to-career correlation that we really care about in most value-added applications. And so when people are saying that the year-to-year correlation is 0.35 to 0.5, and typically people find towards the lower end, around 0.35 when working with ELA, and they find towards the higher end when working with math. What they're saying when they say that is that the correlation between a single year and the career value added is 0.6 to 0.7. So rather than implying that value added doesn't tell you very much, when people say the year-to-year correlation is just 0.35 to 0.5, what they're saying is it tells you quite a bit about a teacher's career effect. Okay, now what does 0.6 to 0.7 mean? I mean, so in this graph, in the red bars, we've just sorted people by their actual career average. So there were 3 different districts where we had value-added data for a large group of teachers for 6 or more years. So we could calculate their career value added. And the red lines are saying, okay, what is the difference in effectiveness that you get if you sort people by the quartile on their career value added? The blue lines are what's the difference in career value added that you get if you just sort people by the single year of value added measure. And what you're saying when you say the correlation is 0.6 to 0.7 is that you get about 2/3 of the difference that you would get if you'd use the career average differences, which is quite a substantial amount. Now you could do even better if you averaged more than 1 year. But what this is saying is that 1 year is telling you an awful lot. Okay, now in order to calculate, when I did that calculation before, when I showed, okay, this is just like the correlation between a test score measure and true score, one little, assumption I made there was that a teacher's underlying value added is equivalent to their career value added. So we're sort of implicitly assuming when we do that calculation that a teacher's effectiveness after the first few years is relatively fixed, and value added bounces above and below that long-term average over the rest of their career. Now, that's a testable hypothesis. And so what we did here was we said, okay, again, there were 3 districts where we could actually calculate the career value added, where this wasn't just a hypothetical calculation we were doing. And we could say, okay, well, what's the year-to-year correlation in those 3 different districts in math and ELA? Then we said, okay, what would be the implied year to career if that assumption is right, that the underlying true value added is fairly fixed over their career? And then, so that correlation, 0.65 to 0.78. When you look at the actual year to career, it's actually quite close to that. So this assumption that the single year tells you a lot about what that teacher's effectiveness will be over the career is not just a hypothetical calculation. It seems to be borne out in the data, at least in these 3 districts. All right. Okay. Now, next, I want to switch to the application of hypothesis testing to personnel decisions. And as I said at the beginning, presumed averageness is the wrong criterion to use when making a personnel decision. So, like this, yet, as social scientists, we're very used to using that framework, and so we apply it to any new problem we see, even if it's not appropriate. So I just want to work through the example here, why that's the case. So, this is the sampling distribution under the null hypothesis that a given teacher is equal to the average teacher. And these magnitudes I've calculated to fit about the typical situation where the year-to-year correlation is about 0.5, and the standard deviation in teacher effects is 0.15. So a common situation in these value-added calculations. Now, if reliability is 0.5, basically what you're saying there is that the distribution of true effectiveness looks an awful lot like this. So if you only are saying, okay, we're going to reject the null hypothesis that a teacher is average if they're outside of those red bars, what you're saying is relatively small percentage of teachers will ever be rejected as being average. And so there'd be very few people outside those bars. Now, think about it. When you're making a tenure decision in particular, or when a principal is making a tenure decision, their decision is actually implicitly, whether they think about it this way or not, doesn't really matter. Implicitly, they are making a choice between this teacher that they see in front of them, for whom they'll have a value-added measure and a bunch of other measures, and a potential novice teacher who may be anonymous, who they may not know, but who would love to get a job in that district. And so when a principal is making a decision, they're actually choosing between 2 teachers, not making a decision about one. And in that case, as I've drawn it here, it would have made sense to promote the incumbent teacher because the teacher's effectiveness is greater than the average novice. But if that distribution for the incumbent teacher were to the left of the blue line, what that would be saying is, actually, I could expect students to be better off next year if I didn't tenure this teacher. That's the right threshold, because the types of errors that you could make are symmetric. It's not the situation where hypothesis testing was set up, where you want to set a maximum probability of making a type 1 error and then taking whatever type 2 errors you have to live with. Here, if you're actually making a choice between two teachers, you ought to be picking the teacher where the odds of success are higher. And that threshold, the blue line, would be much closer to the mean than either of those red lines at the end. Okay, now we can have a reasonable discussion of whether or not how much weight to put on value added. But I think the time has come, honestly, where we ought to be asking, okay, what is the case? What would you have to believe in order to argue that value added should have no weight? Well, first, one thing you might have to believe is that value added measures are equivalent to a coin flip. It's not just that they're volatile, but that they're so volatile they provide no information at all. Well, that's demonstrably not true. Two, second thing you might want to believe in order to attach zero value weight to value added would be that value added measures are driven largely by unmeasured differences in students assigned to different teachers' classrooms. That too is Steve showed at the beginning. We did the random assignment experiment to test that hypothesis. And not only did we find that the prior value added measures were predictive, but that the differences you predicted matched about 1-for-1 with the mean differences in achievement that you saw. So far from being evidence that they're so wildly biased that you shouldn't put any weight on them, actually what it's saying is the evidence is saying actually that they do carry some valid measures of teachers' effects. So that common thing would go away. Third, value-added measures are not reflective of teachers' practice. Well, as we've just heard from a couple of the presentations, the teachers with higher value-added tend to do better on some of the other measures that we've recognized for a long time constitute effective practice. So, yes, value-added measures are not directly measuring components of practice that we're used to using, but they're related to those measures of effective practice that we're used to using. So that would seem to go away. Fourth, teachers with high value-added scores are just teaching test-taking skills. They're not teaching anything of value. Well, in the MET study, we actually looked at performance on some alternative assessments that weren't just the state tests, that were testing students' conceptual understanding. And on those, the teachers who did better on the value-added measures also tended to do better on those measures as well. It wasn't a perfect correlation, but to argue that there was no relationship is just not supported by the evidence. Moreover, there was a paper by Raj Chetty from the Harvard Economics Department and some co-authors recently that looked at earnings later at age 29 and found that the teachers with higher value added contemporaneously also had students who had higher earnings later. So there's just no evidence to support this argument that teachers with high value added scores are teaching nothing of value to students. A fifth argument that I often hear is, I get quoted Campbell's law. So the more any quantitative social indicator is used for social decision making, the more subject it will be to corruption pressures, and the more apt it will be to distort and corrupt the social processes it is intended to monitor. I would encourage anybody who's cited this quote before who cited Campbell's Law to go read Campbell. Because if you do, later on, just a couple of paragraphs later, he wrote, and the highlighting is mine, he didn't have Adobe PDF back in 1976, many commentators, including myself, assume that the use of multiple indicators, all recognized as imperfect, will alleviate the problem. So the answer, when we started this whole process, there were two very different camps. There was the value-added only camp, and there was the anything but value-added camp. The whole point of the MET project was to see to what extent these things overlap. And I think and there was nobody in the middle, hardly anybody in the middle. And what we've discovered, I think, is from the MET project, the most important lesson from the MET project is that the evidence is pointing where it should have been obvious to all of us at the beginning that it's the combination of the value added and the other measures that will provide the most valid measures of teachers' effectiveness.
Thanks, Tom. We've got time for a couple questions for Tom. Yes?
So when discussing stats in this context, why are we not talking about parametric and non-parametric procedures? So second part to that is, well, do these underlying assumptions behind those procedures not matter in this context?
Can you repeat the question?
So I think the question was, why not use non-parametric measures or test these relationships non-parametrically?
And why don't we talk about parametric versus non-parametric procedures in the context of this?
So do you have is there a particular one of these analyses that you've seen today that might have been different, if we'd done it non-parametrically? And because that would be a testable hypothesis that, that somebody could do using the MET data. I mean, obviously, one of the great things about parametric assumptions is they simplify things. They make it easier to focus on a few things. And as everybody has said up here, it's an incredibly complex data set. And in our first pass through, we thought that, that parametrics, making parametric assumptions would be the way to do this analysis, but hopefully people could go back through later and see whether there was some cost to that decision.
Yeah, I think that's one of the values of the conversation today about looking at the data set from different angles and different assumptions. Another question. Yes.
I was wondering, maybe this wasn't a part of your paper, but if anyone has done kind of a cost-benefit analysis on the value-added models, the cost to the states and districts, but also cost of instructional time to students, anxiety, psychological costs as well.
So not as far as I know have people done that careful cost accounting. I think, though, that if you did, you'd find out that the most costly part is the classroom observation. Why? Well, because it involves a lot of adult time, and adults are really expensive. So, like people like Dan and I and Ron and everybody else on this panel, we're number crunchers. At least Dan's expensive. I'm not. But the point is, you get to spread it over tens of thousands of students. A classroom observation, you have to rely on a principal, and the principal's time, like any adult's time, is expensive.
Tom and I are going to have a debate about how expensive value-added and observation is sometime. Another question. Yes.
The proposition that year-to-year changes or year-to-year differences are a good predictor of year-to-career differences. Do you worry a little about the implications of that in terms of the bazillions of dollars that we're spending on professional development? It seems like this argues for a a good sorting kind of approach, but not so much a capital building approach.
So what we described is the relationship between value added year to year and year to career in the current world. And I think actually it may reflect the fact that the professional development that we spend billions of dollars on, most studies have found very little effect. And our results would certainly be consistent with that. Now, even in a world where value-added measures, where professional development was much higher quality, I still think the analysis that we did would be the right one because it is but for a professional development improvement, what kinds of performance could you expect in the future? It's sort of an untested proposition that we've all got to be working on, and I've got a couple of projects going on it, and I know other folks on this panel do too. We've got to be much more focused on how do we actually change practice, and we've got to start that with the recognition that past efforts to change practice haven't changed practice. So we have to have some hypothesis for why. And my own hypothesis is that the past efforts at professional development didn't start with a personalized diagnosis of your particular strengths and weaknesses and didn't follow it up with a personalized measure of your own growth. So I actually think that, it's a testable thing and we'll see, but my hope is that with the existence of the evaluation systems in more sites, ironically, we will see more growth in the future, see a larger impact from professional development investments because there's more data for teachers about what their particular strengths and weaknesses are at the beginning, and there's better measures of improvement if they subsequently improve.
I'm going to call Dan McCaffrey up, and just to follow up on that, Eric alluded to this in our paper, but our research group and a few others have demonstrated that actually if you do tie, in the same way Tom just described, very closely prescribed professional development to practice, you do see gains in practice and then see gains on the value-added measures that are aligned to that practice. So I think, you're absolutely right. This is a very loose system that is not particularly tightly aligned or focused, and therefore a lot of money being spent, but it's kind of an untested hypothesis right now whether one can gain more from a capital development a solution that's better informed and or a selection solution that's also informed. Dan.
There's full screen, yeah. Great. All right, thanks. Where's mine? There we go. Good. Yeah, before I jump into everything, I want to recognize my co-author, Kata Mile. She actually did all the work here mostly, and I'm just here presenting it, but she's not here because she's on maternity leave, so I guess she couldn't be drugged away. Yeah, that's right. It's really hard to... and it's kind of unfortunate that she isn't here because it would have sort of broken the gender bias we have up here. Yeah, that's true. I really don't want to go there, but so anyhow, I'm going to talk a little more about classroom observations. We've been going over them, and they're really, everyone's paying a lot of attention to them. We've got states sort of mandating that people use them. And all the stuff we were just talking about, all the ways in which they are useful and they predict things, and that they can be used in ways to improve teaching, and they've been shown in studies to do all that. So they're really creating a lot of interest, and now it's really becoming part of not only teacher evaluation, it's also very central to the research we're doing about teaching and other ways. And so if we're going to put all that emphasis on these measures, I think we really need to sort of rely on the fact that these measures are really doing what they want, and they really are measuring what they're supposed to be measuring. They're really functioning the way we want them to work. And one of the key things when we think about that is that they really need to be invariant to the context of teachers teaching them. We're assuming that we can apply these to any teacher that's out there doing various different things, and we really need to make sure that they are doing that. And so one context in which we might be worried about this being true is the grade level and the age of the students that they're teaching. Because we know, as we're going from students who are young to old, that there are quite a lot of differences among students who are in elementary school versus students who are in middle school. We know also that when we look at other ways that we've looked at ways measuring teachers, more informal evaluations from principals, that principals tend to give lower measures, lower values to middle school teachers than they do to elementary school teachers. When we look at small studies that are sort of outside the kind of measures we're talking about here today, that have looked at these things in the past, they've also found some evidence that middle school teachers tend to get lower scores. Middle school teachers report doing different things in their classes than elementary school teachers do, so maybe there are differences. So, you know, there's this potential that there might really be differences, and we need to really start questioning, you know, can we find evidence? Is there any way? Do we see these differences? And then what can we think about whether that's really telling us something about the measure or telling us something about the teaching? Is there any way we can sort any of this out? So the goals of what we wanted to do here was to sort of use the MET data and determine whether there were any grade-to-grade differences in the observation scores that we see. And if there are any, then we wanted to see if there were any things in the data that might help us understand sort of what those sources might be or why they're there, and if any way we can sort of sort out what they really mean. And then we also wanted to see if the relationship between observation scores and student gains were different across different grade levels. And I'll get a little bit more about the motivation for that in this slide, actually. So, like, why might we see differences? And I think as we start to think about these differences, and we'll talk about how we try and sort of sort some of these things out and whether we can actually sort them out. It may really be that the teaching's different. You know, it may really be that, you know, middle school teachers are less effective, and they're sorting in a way that the teachers who are less effective wind up being in middle schools. I think people who have middle school children would sort of attest that that might be something that would happen. There may also be that there's just rater errors, that something about what's going on in middle schools might look different. And in particular, in the MET data, we might find that the MET data was not a random sample, so it could be that the teachers who decided to participate in the elementary schools or the middle schools were different in ways that were being observed by the raters and were influencing what the raters were saying. So it may just be something spurious there. It may also just be something different about the way middle school classes look that might be sort of being picked up that way. It may be that the students are different in ways that make it harder or easier. So it may be that middle school students just, they are developmentally different. Maybe the way they behave, the way they interact with the teachers, they just do not, even for an equally effective teacher doing the equally good things, that, what's happening in that classroom just doesn't look as good or isn't as good or just doesn't resonate as well with the measure. And it may be that the kinds of measures that, the kinds of things that you want to do for a middle school student to be effective are different than the kinds of things you would want to do with an elementary school student to be effective. And it may be that the kinds of things these observations protocol privilege are better aligned with one or the other. So maybe whatever they like, whatever they think is really good teaching, looks a lot like things that are good for what you would want to do for a middle school classroom, but they don't look quite as good for an elementary school classroom, or vice versa. So we want to sort of see if any of these things are there. So what we want to do now is we want to sort of see if we find any differences, and then use the data we had to see if any way we can kind of learn a little bit about these various potential reasons we might see differences. It would be nice if we could say that we could strongly test them, but I don't think we can really strongly test them, but we can at least get some sense if there's anything we can rule out. So we're going to use the MET observation data. We're using data from 1,634 classrooms. We didn't use all the data because we needed teachers who we needed to rely on some of the districts, so we're not using quite everybody. When we're going to focus on 3 of the observation protocols, I wasn't here for the first talk, so I don't know if all the protocols were discussed, but we're going to focus on the classroom, which we definitely heard something about, and the FFT, which we heard something about. And then we're also going to to focus a little bit on the Plato, which was an English language arts, the protocol for language arts teaching observations. For each protocol, the classroom interactions were were measured on multiple dimensions, and then they're sort of summed up to the domains, and then they're averaged up. And they're all kind of the same in that sense, and they're, Plato is pretty much the same as all the others, and you've seen the dimensions of some of the other ones. As was mentioned earlier, class and FFT are generic in the sense that they can be used for both math and ELA classes, and we'll talk about how they work in both math and ELA classes. And as the name of Plato might suggest, it is focused for English language arts classes, so we'll talk about how it works in English language arts classes. It's going to be important. We're going to talk about differences. We need to think about what the score range is. Plato and FFT are scored on a 1 to 4 point scale, and classes on a 1 to 7 point scale. So we'll need to keep that in mind when I start showing you any of the data. So now what we want to do is sort of say, okay, if we see any differences, what can we use in this data to sort of tease this apart a little? One of the things that like I mentioned, we only focus on some of the districts. We're using 3 of the districts, not all 6. The other 3 districts either didn't have any teachers at some of the grade levels, or in Memphis they had teachers at every grade level, but they had very few middle school teachers in some of the subjects, so we didn't include them in the study. And we're going to use some district data to help us sort out various things, to sort of create sort of measures of the classroom context, to sort of separate out those pieces. And those are pretty standard demographic kinds of things: race, ethnicity, gender, those kinds of things. But we're also lucky because we do have the tripod survey in these classes, so we can build a sort of a richer picture of the classroom context than you would usually have. And we're actually focusing on some of the questions Ron didn't. I don't think he mentioned any of these. So we're focusing on some of the questions he didn't mention that tell us more about sort of the kids' background. So whether they read books, whether they do homework, whether they have computers, and what their home life is a little bit about. So we're going to use these to sort of build up a little bit of measure of classroom context. We're also going to try and sort out a little bit about teachers, and we're going to look at race, ethnicity. And you might say, why are you looking at that? And in fact, when someone reviewed this chapter, they said, is that really appropriate? It's like, well, it's an identifiable characteristic of the teacher, and we don't know if that might have an influence on what the raters are thinking, and we don't know at this point, we need to look at it and see whether it's differential across the middle school. So it's a possible thing. Then we're also going to look at things that might be related to whether or not how effective the teacher really is, years of experience, and all the teachers took content knowledge tests, and so we also have those scores. Then, as I said, we wanted to see whether the relationship between the measures relationship to growth differed between elementary and middle school teachers, so we also have growth measures. We use value added, and I think the most important thing there is, as Tom pointed out, we have value added both in the district test and we also have it in supplemental tests. So our basic analysis plan is we're going to sort of see if there are any differences. We're going to average everything up to the classroom, and then we'll see if there are grade level differences. We're going to pool all the data across the districts, and we'll also mention about how things look differently by districts. And all the things I'm going to look at, we're going to look at things separately by ELA and math. Then we're going to control for these various sorts of characteristics to sort of see if we looked at teachers who all had the same characteristics, do we still see this? If we look at classrooms that are the same, do we still see any grade level differences? If we look within the same schools, do we see grade level differences? And and then we're going to sort of see, do we see relationships between differences? We use linear regression to look at all this, and we start off looking at all the districts, and then we focus on Hillsborough because we had better data and it was more consistent there. Although, as I'll say right now, what we do find is that the results are pretty similar across all the districts at this level. So what this shows is the average score for teachers in grades 4, 5, 6, 7, and 8. And what we have here is we have class in ELA and math, and we have FFT, ELA and math, and Plato. And remember, so the score range for class is a range on 7 points. So we're looking here at a restricted range, but basically we're seeing a difference between, whoa, that is like a trigger there, isn't it? Wait a second, I went backwards. Sorry about this. What we're seeing is about a difference of about 0.6 difference between 8th grade teachers and 4th grade teachers. And we see that kind of consistently. We see similar things in math and ELA on class, and that's a pretty big difference. If we compare that to the variability across the sample, that would actually be a pretty large amount of variability. So this is not a really trivial difference. And as we saw with the distributions earlier. That's a pretty big difference. And we see also differences in FFT and Plato. And remember, they're just on a 4-point scale, so something about 0.2 to 0.4 of a difference on that scale is actually quite large as well. So these are really pretty big differences. What's most striking is that if we look at every one of the districts, we see this. We look at every one of the protocols, we see this. We look at almost all the different components of the protocols, we see this. There are some where we don't see it, but very consistently we see this pattern over and over again. So now we want to sort of start, teasing this out. So we're going to turn over to the Hillsborough data and say, okay, well, if we sort of said, what if we looked at similar teachers, do we still see this? Is it something about the teachers? When we control for teachers, we really don't see much of a change. We see pretty much the same things going on. When we sort of also control for the classroom context, again, we really don't see much change in what's going on. This is the ELA. We do see a little bit more when we control for the classroom context in the ELA. We see things changing a little. It's a little bit smaller than it was otherwise. But by and large, even though we've controlled for these things, we're still seeing significant differences across the classes. And just as evidence, we also see that in FFT, and we also see it in Plato. And here, as you can see, when we're looking at Plato, we're not seeing any differences. One thing I forgot to mention. When we're looking here, sorry for all the flipping around. When we're looking here, one of the things we can add is for FFT and Plato, the exact same instrument is used across all the grades. So there was raters who rated elementary school teachers and classrooms, and raters who rated middle school classrooms. So not only could we control for the teachers, the context, we could control for the raters as well. And so the last set of bars is actually when we control for the raters as well. So what you can see is no matter what we control for, we're seeing pretty much the same effects. And that's just sort of seeing the same things. We actually, this title was wrong, and I realized that today after I'd given Carrie my slides so she could put them here. But this is to say, if we look at teachers in the same school, so we look at 6th, 7th, and 8th grade teachers all in the same school, we don't see any difference. We also looked at this relationship with growth, and did we see a difference? Like maybe middle school teachers are doing a good job, but what we're measuring is important with middle school teachers. We don't see any evidence of that. And in fact, if there was any evidence, it looks like the measures are a little stronger related to growth for middle school teachers, but it's not significant, so there really isn't much difference. So in summary, we do see differences, and we couldn't really explain them very well with the things we have. So what are the implications? I think the key issue with the implications is we have two potential sources here. I think from my takeaway on this, it really looks like there are differences in the teaching. But now what is the source of that? Is it the teachers or is it the student context? And that we really can't sort out. In fact, that's a really hard thing to sort out. And we don't have many teachers. In fact, we couldn't find any teachers who teach both 4th and 8th grade, so we really wouldn't be able to do that. So it's a really hard issue to focus on, to cut apart. And given the uncertainty we have, if you try and use them unadjusted or make adjustments for grade level, there's potential sort of having some negative impact in one way or the other. But one way to sort of, I think, to reduce that impact is to focus more on the teaching rather than the teachers. Because the evidence is that the teaching is less effective in the 8th, 7th, and 8th grade. And if we, regardless of the source of that, whether it's students or teachers, if we focus on trying to improve that teaching, we would have less opportunity for negative consequences than we would if we were specifically using it to sort of say, okay, these teachers are poor and what the consequences would be.
Thanks very much, Dan. And we've got a couple minutes for questions, if people have questions for Dan on his paper. Yes?
Yeah. You asking me? Yeah, you do find that as they get older, they rate their teachers a bit lower. And so if you're doing stuff for accountability, you want to norm within grade level. How's you going to do?
I was just whispering to Steve on one of these. We find differences if in smaller studies, we're going to do this in MET, whether the 6th grade is organized in a middle school setting or is organized in an elementary school setting, the differences in the teaching there. Another question for Dan? You got it.
Repeat the question.
The question was, we would have students if we track students over time. So I don't think that would help because we won't have any of these we won't have the actual, we wouldn't have the classroom measures of those students' teachers when they're in 4th and 8th grade, because we only have the 2-year slices of the sort of classroom observation measures in that. But in terms of data, we are collecting data from the districts from the first year, from like the, now I have to remember the years, so if I screw up the years, but like from 09-10 to 3 years past the end of Met. So there will be, I think, 6 years in which we will have panel data on the students from each of the districts that's going to become part of the longitudinal database. I don't know exactly how they're going to manage that, whether you're going to be able to link those students across time or not, but there will be, that data will be there. If they set it up in a way that could be linked, then people could do those longitudinal analyses themselves. I just don't know exactly. I know the data is going to be there. I don't know how it's going to be shared in the database. I'm looking at George because George would know that answer.
Okay, we need actually to wind up and close the session. And so doing, I want to just make 2 comments. First, I want to thank Carrie Kerr for her steadfast organization of this group, for the symposium, for the volume, and for the Met study. Thanks, Carrie. Just very quickly to put in a pitch for the data set. This is an extraordinary resource for education science, particularly around scientific work and teaching. I think you just got a very, very small glimpse of the kinds of things that can be done and the implications on the scientific side and the very, very important implications on the applied side. So I would follow Steve's lead in encouraging you to chase down the data set and use it. Thanks all very much for coming.